Okay, now calculating capacitance. Sometimes you're given a physical sort of description of a capacitor and you use this formula here, which I think we just worked out was that. And so they might give you an area and a distance. One thing to remember, areas, converting areas. Even some of my school kids get this wrong. How do you convert square millimeters into square meters? You divide by 1,000,000, because 1,000 times 1,000 is 1,000,000. So there are 1,000,000 square millimeters in 1 square meter. So if this was in square millimeters, I would have to divide it by 1,000,000 to get square meters. Distances are often in millimeters. You only have to divide by 1,000 to convert to meters. All right, enough on that. Let's look at circuits. Now we've got a series rule and a parallel rule for how you add capacitances. Now with the series, and this is going to be real easy for you to remember because you already know about resistors, right? If we've got, let's have a look here. So, capacitors. Let's make this one 4, 4, and 6. 4 microfarads, 4 microfarads, 6 microfarads, 4 microfarads, 4 microfarads, 6 microfarads. Now the series circuit does the opposite thing from the parallel circuit. Sorry, from the resistors series circuit. So this formula is complicated, this is simple. These ones add like series, which is C total equals C1 plus C2 plus C3. The way you do these guys is you just add them up. So that's 8 and 6, that's 14 microfarads. Simple. What's the voltage across? The voltage across each one is the voltage across the circuit. Right, so that's V. How do you find the charge on each one? Well, that's just the voltage. Remember, the capacitor formula is charge per volt. So charge equals capacitance times voltage. So capacitance times voltage, right? Did we make any mistakes there? I think not. All right, just multiply it, the capacitance times the voltage, and you'll get the charge. 4 microfarads times voltage will give you the charge in coulombs. Very easy. So which one has the bigger charge? The 6 microfarad. That's the easy one. Series one is like the parallel circuits and resistors, right? Not quite so easy. So with that one, we've got the 4, 6 microfarads, and we've got a certain voltage. We here use the formula just like with the resistors. So that's 1 over 4 microfarads, 1 over 4 microfarads plus 1 over 6 microfarads. We do that on our little calculator, and what do we end up getting? I think we get, well, 1 quarter plus 1 quarter plus 1/6. You can see 1 quarter is about 1/2, and 1/6 is a little bit over. It's a little bit over that. It's a little bit over 1/2, maybe 0.6, 1 over 0.6. Anyway, it comes out at 1.5 times 10 to the minus 6 farads. So you've got a total capacitance. It's like you've got one capacitor there now. All right. So with one capacitor, if I want to know the charge, all right, then as I said before, charge equals volts times capacitance. So I know the voltage across the whole thing, and I know the total. Capacitance. So if this had a voltage of 12 volts, all right, and I've said it has that charge, let's just do it on our calculator. We're saying the voltage of 12 times the capacitance, which is 1.5 exponent minus 6, then we end up with a charge of 0.00018, and that's our charge. Now, the thing is, that's the charge when we look at the total capacitance. It's not the charge, well, it is the charge for each one. Because, as I said when I talked about it initially, if this one here is, if that's positive and that's negative, then that's positive, negative, negative, positive, positive, negative, negative, positive, positive, negative, negative, right? And the charge on each of those will be this one here, the 1, 2, 3, 4, 5, 1.8 times 10 to the negative 5 coulombs. That's the charge on each of these plates. Now, if that's the charge on each of those plates, then we can work out the voltage. We've got that 0.000, so let's work it out on the 4. Because voltage, we said that capacitance is charge per voltage, so voltage is just charge divided by capacitance. So we've got that 0.00018. So let's divide that by our 4 microfarads, and I end up with 4.5. So this guy has 4.5 volts. This guy has 4.5 volts, because it's the same calculation. 9 volts, I think you're getting the idea. That last one's going to have 3 volts. So let's do it, that one. Let's divide that one by 6 microfarads. No, it didn't give it to me. Let's do it again. Three, as predicted. So series are a little bit tricky. You work out the total capacitance, then using the total capacitance, you use the voltage, the total voltage, to work out the charge on each one in the series circuit. Then once you've got the charge, you can use the charge and that one's individual capacitance to work out the voltage drop across it. Notice here, the bigger the capacitor, the smaller the voltage drop. All right, bigger cap in series, smaller voltage drop. One of those interesting things to remember for some of those questions. All right, that's capacitors. How do you calculate series and